last video talking about 4.3. 4.3 is log scales. In general, we talked about the blue and the green, the linear scale in blue and the log scale in green. And the log scale kind of allows us to take a look at some very, very big numbers on kind of the same scale. So the very big numbers would be in the blue. On the linear scale, a big range of numbers on the blue scale can be kind of put onto maybe a more compact scale and an easier scale to look at on the log scale in the green. So we talked about pH scales, we talked about decibel scales, we talked about a magnitude. If I give you a 4 times as strong earthquake, we just simply rewrite it as log of 4 times the intensity over S and kind of separate out that log base 4, or that log, give it its own house of log, and that's what adds to the magnitude. The log of that intensity, the multiplication of that intensity, becomes what we add to the Richter scale, because the Richter scale is a log scale. So let's take a look at maybe another example of Richter scales and say, what happens if I want to compare a scale or a magnitude, let's say 9.1. Magnitude equals 9.1, or one earthquake. And another earthquake is magnitude equals 7.9. How many times more intense is that 9.1 versus the 7.9 Richter scale? Well, if we take a look at our definition, magnitude equals log of the intensity over S, some intensity over S. We need to find out what that intensity is and compare this intensity of, let's say, the big one to the smaller one. So we're going to find out, we're going to redefine all this information, all of this magnitude in terms of intensity, and then compare the intensities. So this 9.1, here's the big one. This is the big one. Big one is 9.1, 9.1 equals log base 10 of some intensity, that big intensity, over S. And we're going to rewrite this log in terms of S. So we know that we can break this out as 10 to the 9.1 equals intensity, the big intensity, over S. And then just multiply S times each side, or each side times S to get rid of this S over here. S times 10 to the 9.1 equals this intensity, the big intensity. Over here, we'll take a look at our magnitude 7.9 and kind of do the same thing. 7.9 equals log of intensity small over S, some standard S. This S is different from that S. I'm just calling this as a subscript for this intensity. We do the same thing. We can convert this log equation to an exponential equation by saying 10 to the 7.9 equals intensity small over S, and then multiply each side by S to get S times 10 to the 7.9 power equals some intensity small. That's the small intensity. This is the big intensity. All I did was just kind of rewrite everything in terms of, instead of in terms of logs, we wrote it into a exponential equation. So let's compare now how many times bigger this intensity is than that intensity. So let's take a look at this. Intensity big over intensity small, and find out how many more times this is bigger than that. Well, intensity big, let's rewrite. We'll just rewrite this down here. S times 10 to the 9.1. That's our big intensity. Small intensity is over here. Some S standard times 10 to the 7.9. We really don't even need to know that the S standard, because that cancels out. S divided by S is 1. How many times bigger is this than is the big one versus the small one? It's 10 to the 9.1 divided by 10 to the 7.9 is, if we've got exponents, if we've got exponential statements, and we've got the same base, we can subtract the exponents here. This would be 10 to the 9.1 minus 7.9 equals 10 to the 1.2 power. 9.1 minus 7.9 is 1.2. That's pretty close to 16. It's 15.9 or something like that, 15.8, something like that. But we'll call it about 16. So this intensity, this big intensity, is about 16 times bigger than this small intensity, which kind of goes along with what we've been talking about. If we talk about that linear scale here, here's our linear scale of intensities. which is what we've included in our equations up here, the intensities. If we compare that to the log scale of the Richter scale, this would be a log scale of the Richter scale. It would be our Richter scale. Richter scale is these numbers over here, these magnitudes here. 7.9 is on the Richter scale, 9.1 is on the Richter scale, because they are logs of these numbers here. If we go from a, well, let's see, in our example it was 5 to 8. If we went from a 5 to an 8, how much more intense is the 5 or the 8 compared to the 5? It would be 8 minus 5 is 3, so up here it would be 10 to the third power times as powerful, because this is a log scale, this is a standard linear scale. If we go from a 9.1, if we go from a 9.1 here versus a 7.9, if we go from a 7.9 to a 9.1, or 9.1 versus a 7.9, how many more times is that intense? Then the smaller one is the bigger one than the smaller one. It would be 10 to the 9.1 minus 7.9. 10 to the 1.2. 10 to the 1.2 is about 16. So up here it'd be 16 times as powerful, going from 7.9 to 9.1. Going from 5 to 8, it's 3 times more powerful on the log scale, but 3 times more powerful on a log scale converts to 10 to the third times more powerful on a linear scale. So the shortcut is, if I give you two Richter scale measurements, 9.1 and 7.9, and I want to say how much more intense is it, subtract the numbers on the Richter scale, and take that number, 9.1 minus 7.9, take that as the exponent of 10, and 10 to that power is how many times more powerful that is, about